In the previous video, we understood the alternate angles test, and this is what it said. If a pair of alternate interior angles formed by a transversal of two coplanar lines are congruent, then the lines are parallel. Now let's look at its converse. If two lines are parallel, then the alternate angles formed by a transversal are congruent. In the converse, we are given that the lines are parallel, and we have to prove that the alternate interior angles are congruent. To prove the converse of the alternate angles test, we need to represent the given data diagrammatically. Let's erase this. In the converse of the test, we are given that the lines are parallel, and we need to prove that the alternate interior angles are congruent. So we draw two parallel lines first. This is line P, which can also be called line AB, and this is line Q, which is drawn parallel to line P. And we have the transversal R or transversal EF, which intersects the two lines at two distinct points G and H. Now we have our diagram ready, and all we need to do now is write down what we know and what we have to prove. What we know will be written in the given section. The only thing that we know is that line P is parallel to line Q. We have to prove that the alternate angles formed are congruent. We have to prove that angle AGH is congruent to angle GHD. This is one of the pairs of interior angles. Since the data we have is minimal, the best way to proceed would be by using indirect proof. So we assume that angle AGH is not congruent to angle GHD. We are assuming that the interior angles are not equal. The next step that we're about to perform is quite amazing. We draw a line S through point G such that the interior angles formed are equal. So we draw a line S like this and name it line JK. Now just focus on line S and line Q. We have drawn S such that their interior angles are equal. Angle JGH is congruent to angle GHD. Line R is also transversal for lines S and Q. As its interior angles are congruent, we can say that line S is parallel to line Q because it satisfied the alternate angles test. But wait, line P is parallel to line Q? This data is given to us. This means that line S and line P pass through point G and are parallel to line Q. Is that possible? The best way to find out the answer is by drawing a simple figure. If we have a line and a point not on it, there can exist only one line which passes through the point and is parallel to the line. This is called uniqueness of parallel lines. There cannot be two distinct lines passing through point G which are both parallel to line Q. So our assumption is wrong. There cannot be another line S which is parallel to line Q and which also passes through point G. This tells us that line P is parallel to line Q and angle AGH is congruent to angle GHD. Let's review what we just did. We knew that lines P and Q are parallel. We had to prove that the alternate interior angles are congruent. Using indirect proof, we assume that they are not congruent. We then drew another line through point G such that the alternate interior angles are congruent. As the alternate interior angles are congruent, we could say that line S is parallel to line Q. But only one line can pass through a point that is parallel to line Q. So a distinct line S cannot exist, which makes our assumption wrong. And this proves that the alternate interior angles are congruent.